Hi everyone. I want to make sure that we know how to kind of work through some of these tables. So I'm going to go through a couple of these just really quickly. So pay attention to how we do this. You're going to need to use the tables to finish off the rest of this. And then we have another set of kind of situations that you're going to have to work with on for the next part of the fractional proportional relationship. So I'm going to go through the train section. So here we have a train traveling at a constant speed. So we talked about this in several classes, but here is what a lot of students circle to begin with. And this is a rate that is certain. However, we are being asked to circle where the unit rate is. So unit rate is per 1. That's what it means. So miles per gallon. How many miles can I travel in 1 gallon? Dollars per pound. How many dollars do I pay for 1 pound? These are unit rates, and we find those whenever there is a 1 in the table, or in this case a 1 on the number line. That relationship is the same as this relationship, right? So the relationship is the same. The name of this is a unit rate. Now, here's the nice thing about unit rates, right? A unit rate is equal to K, which is our constant proportionality. So there's my constant, right? So if I wanted to find the constant proportionality, I would want to find the unit rate. Okay, so next screen, we talked about labels. The labels would be, in this case, 7.5 kilometers in 6 minutes. So our labels would be kilometers or distance and minutes or time. Okay, and here we do set it up, distance and time. Now, generally you will see time on this column. Time is almost always on the x-axis, but for this particular situation, it's set up as distance and time. And in a proportional relationship, it's okay to do it either direction. So we can add rows to this, and the table works really nice. So let's start with what we know. In this case, what we know is that 7.5 kilometers is 6 minutes. That's how far the train can travel. Okay? So if I added another row here, some rows are really, really nice. Like a 1 is a really nice row to have because that's my unit rate. So how do I get a 1 there? Well, I could get the 1 and I can let Desmos do the work. 7.5 divided by 7.5. That's what I know here, and so I use that to get that. And that means that for this row, I have to take my 6 and divide by 7.5, and I have this 8/10. That's my unit rate. So that's also K. It's my constant proportionality. So if I wanted 5 here, this would be the constant times 5. That's how I could calculate all these other things. If I wanted to know, let's say it was the next town was 25 miles away, how long would it take me to get there? Well, I would do 0.8 times 25. Okay? So there we go. Next screen. How far does a train go in 1 minute? Okay, so I need 1 minute. So here we go. Distance, time. I need this to be a 1. Right? So if this is a 1, then I can use anything that I already know. Right? Any of these relationships are the same. So I can use any of those. So in this case, I'm going to use the first one. So I'm going to say 6 divided by 6. Right? That gives me 1. And over here, I'm going to take that 7 and 5/10, and I'm going to divide by 6. Okay? So I can go 1 and 25/100 kilometers, okay, in 1 minute. So let's test it. I get it right. Okay, so the next screen. Okay. Now I need to know 100 minutes. Actually, if I know this is 1 minute, okay, then that's a pretty straightforward one, right? So if this is 100 minutes, then this is times 100, 125. So let's test it, 125. And it's a check, and then I need to explain that, right? So I did it on the table, I showed my work on the table, now I need to explain it. Okay? And now we're up to Lynn and Noah, and we can use this, all the work I did here, how I set all those up, can be used as I work through Lynn and Noah. Right? Set up my labels, okay? Miles, hours, so we're talking about distance and time again. All right? Good luck to you.